Morning, students. Let's begin with the today's topic. Let's begin. Okay. In previous class, we were discussing about general packet radio services, how it is used in communication, but especially in mobile phone and mobile network and all. Right. So we discussed this in last class. In today's class, let's begin with the embedded firmware. Right. Uh, Firmware nothing but the software. The software what we use in order to run the embedded systems. The meaning. Embedded firmware refers to the control algorithm, nothing but the program instructions and or the configuration settings that an embedded system developer dumps into the code memory of the embedded system. Like whatever the developer or the programmer writes code for the embedded system is called as the embedded firmware. It is very simple. He has given what are the kind of different kind of systems we can use, programs we can use, the codes we can use. Write the program in the high level language like embedded C or C++. I can write the code using the embedded C uh, or using C++, and also I can write the assembly program what we write in the keel end of. So as given on the IDE, that is integrated development environment, right? So best example is keel microvision. What the software we have, right? That is the IDE we have. That is keel microvision, nothing but the mu vision microvision 4.7.4, right? Using that one, I can write program for the family members of ARM7. I'm telling what the IDE, the kind of IDE we are using in our lab. Already you are familiar with that. That is Mi Vision 4.74. So where I can write program for the family of ARM7 processors. LPC 2148 is one such kind family. So same thing is here, given here. Keel Microvision 3 IDE is used for all family members of 8051. Right? Yes. So I can write program using embed C, like high level languages embed C or the C++, or I can use them, or I can write program using assembly language. So very simple, like whatever the program you write, whether in the higher level language or in assembly language, you need to convert them into machine equivalent or the machine understandable. That is given here. The instruction set for each family processor controller is different, and the program written in either of the methods given above should be converted into a processor understandable machine code before leading into the loading into the program memory. The process of converting the program written in either a high level language or in the processor controller specific assembly code to machine readable binary code is called as the hex file creation ಅಂತ ಹೇಳ್ತಾರೆ. But usually remember, it's very important point, we are not creating any hex file. Okay, still we are dealing with the software programs, you cannot see the hex file created there, but you will see the hex file creation or the hex file created in hardware programs where we use embed C and the C++, and that particular concept, that is converting the higher level language into the machine understandable one, is called as hex file creation. The hex file creation nothing but the machine codes generation and the meaning, very simple, right? Yes. So next, the last part of this module, that is third module, other system components ಅಂತ ಇದೆ. So apart from the communication systems or the components, what are all the other systems available in the, are the components available in the embedded systems ಅಂತ. Okay, just I will brief them. Reset circuit ಅಂತ ಇರುತ್ತೆ, that is used to reset the embedded system. Next, brown out protection circuit ಅಂತ ಇರುತ್ತೆ, whenever the voltage goes low beyond or below the specified voltage, right? Then it is called as the brownout protection, or the brownout, the situation is called as brownout, and protection, to protect that particular condition we use one circuit called as the brownout protection circuit anta adu circuit diagram kottiyara. Next, oscillator unit. Certainly we need one oscillator in order to generate the clock signals. So that is oscillator unit. They are very very important. Okay, 20 marks question barbodu namge. Briefly explain or write a short note on the followings anta kelbodu. ನೆಕ್ಸ್ಟ್ ರಿಯಲ್ ಟೈಮ್ ಕ್ಲಾಕ್ ಅಂದ್ರೆ ಈಗ ನಾವು ಕಂಪ್ಯೂಟರ್ ಆನ್ ಮಾಡಿರ್ತೀವಿ ಅಥವಾ ಲ್ಯಾಪ್ಟಾಪ್ ಆಫ್ ಮಾಡಿರ್ತೀವಿ ಅಥವಾ ಯಾವುದೋ ಒಂದು ಎಂಬೆಡ್ ಸಿಸ್ಟಮ್ ತುಂಬಾ ಸಮಯ ತನಕ ಆಫ್ ಮಾಡಿರ್ತೀವಿ, ಬಟ್ ಆದ್ರೂ ಕೂಡ ಇಟ್ ಮೇಂಟೈನ್ಸ್ ಎ ಕರೆಕ್ಟ್ ಆರ್ ಪ್ರಾಪರ್ ಟೈಮ್. So that is because of the real time clock. And the next one is a watchdog timer. It is very very important, a hardware unit that is used to monitor the program execution or the software execution, right? So we'll discuss them one by one, right, in the next 25 to 30 minutes, right? The first one, uh, reset circuit ನಮಗೆ ಏನಕ್ಕೆ ಬೇಕು? ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, if you are stuck with mobile, smartphone, or if you are stuck with the computers and all, or if you are stuck with any embedded system, so what they do, they simply go for the reset. They press the reset button. So reset button ಒತ್ತಿದಾಗ ಏನಾಗುತ್ತೆ? So whenever you press a reset button, the computer or the processor will start executing the program from a location called as 0x0000 anta, right? So where the initial code or the starting of the that system code is present. So the reset circuit is essential to ensure that the device is not operating at a voltage level where the device is not guaranteed to operate during the system power on. The reset signal brings the internal registers and the different hardware systems of the processor or the controller to a known state and starts the firmware and the software execution from the reset vector. ನಾ ಹೇಳಿದ್ದೆ ನಿಮಗೆ ವೆಕ್ಟರ್ ಇಂಟರಪ್ಟ್ ವೆಕ್ಟರ್ ಟೇಬಲ್ ಅಂತ ಇರುತ್ತೆ, ಇದು ಸೇಮ್ ವೇ ರಿಸೆಟ್ ವೆಕ್ಟರ್ ಅಂತ ಇರುತ್ತೆ, where it has the starting address. The reset vector can be located to an address for processor or the controller supporting the bootloader. The reset signal can be either active low or the active high anta ಹೇಳ್ತಾನೆ. So observe here, these are the two circuits which are used to provide reset for the microcontroller or the processor, right? So observe here, these are all the external devices. Some devices have got inbuilt and some embedded systems have got external to the processor. So this is how it works. Observe here, it's a RC ಅಂದ್ರೆ register and the capacitor, R and C. So here it is active low and the active high is the difference is there is one dedicated pin present over the IC or the microprocessor dedicated pin irutte reset goskara, right? Whenever a signal on that particular pin is high, then it is called as the active high anta ಹೇಳ್ತಾರೆ. Whenever signal on that particular signal is particular pin is low, okay, then it goes into the reset mode, then it is called as active low anta ಹೇಳ್ತಾನೆ. Just observe, VCC is there, it is completely external. Again the VCC, a capacitor is there and the resistor, right? So whenever we press the button, voltage at this particular, because this is reverse bias, so the voltage will move to that particular pin where it is connected, right? So this is called as the active low. And here whenever power supply or whenever this particular button is pressed, the it will become short circuit because the diode is inversely connected here. The current will directly flow to ground and making voltage at this particular point as low or zero. So then the system will get into the reset mode. So that's what it is called as active low, right? Since the processor operation is synchronized to a clock signal, the reset pulse should be wide enough to give time for the clock oscillator to stabilize before the internal reset state starts, right? So the reset signal to the processor can be applied at power on through an external passive reset circuit comprising a capacitor and the resistor or through a standard RC circuit. So ನಾನು ಏನು ಹೇಳಿದೆ ಅದನ್ನೆಲ್ಲ explain ಮಾಡ್ತಾ ಹೋಗಿದ್ದೇನೆ. That's it. Next, coming to the brownout protection circuit. So it's again very very important. Keep in mind brownout. So what is brownout? Brownout protection circuit prevents the processor or the controller from unexpected program execution behavior when the supply voltage to the processor or controller falls below a specified voltage. For example, ಕೆಲವೊಂದೆಲ್ಲ ಎಂಬೆಡ್ ಸಿಸ್ಟಮ್ಸ್ ಬ್ಯಾಟರಿ ಆಪರೇಟೆಡ್ ಇರುತ್ತೆ. ಬ್ಯಾಟರಿ ಆಪರೇಟೆಡ್ ಅಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಅಂದ್ರೆ ವಿ ಪುಟ್ ದ ರೀಚಾರ್ಜಬಲ್ ಬ್ಯಾಟರಿ ಆರ್ ಸಿಂಪ್ಲಿ ಎ ಬ್ಯಾಟರಿ, ರೈಟ್? So if the voltage present in the battery goes below some specified standard, ಅವಾಗ ಏನ್ ಮಾಡುತ್ತೆ, the embedded system is unable to get the required power supply and it will start behaving unusually, right? So in order to avoid this, this particular situation is called as the brownout, and in order to avoid this, they use one circuit called as brownout protection. ಅದನ್ನೇ ಇಲ್ಲಿ ಹೇಳಿದ್ದಾರೆ, brownout protection circuit prevents the processor or the controller from unexpected program execution behavior when the supply voltage to the processor or the controller falls below a specified voltage. Next, justify ಮಾಡ್ತಾ ಹೋಗ್ತಾನೆ. It is it is essential for battery powered devices, since there are greater chances for the battery voltage to drop below the required threshold. Next, the processor behavior may not be predictable if the supply voltage falls below the recommended operating voltage. It may lead to situations like data corruptions. Yes, what is the effect of this brown out? There is a data corruption. You data ಏನು store ಮಾಡಿರ್ತೀರಲ್ವಾ, that may get corrupted. That is a disadvantage of this brownout. So in order to avoid this, they go for the protection circuit. A brownout protection circuit holds the processor or the controller in reset state when the operating voltage falls below the threshold. It's very simple, right? So ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ, whenever the voltage of the battery or the voltage provided by the battery is going down from the specified voltage level, then suddenly again ಮಾಡುತ್ತೆ brownout spot protection, it will put on the reset button. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಅವಾಗ ಏನಾಗುತ್ತೆ, it will avoid the data corruption, nothing but it will avoid the device get into the unusual behavior. So that's a point you need to remember. That's it. So you can observe here, brownout protection circuit with the active low output ಅಂತ ಇದೆ, nothing but this particular pin is connected to the reset one, right? So whenever the voltage uh, in the battery goes down from the specified voltage, so it gets activated, nothing but the voltage at this particular point will become zero, and this is connected to the reset button of the microcontroller, right? So that's it, very simple, just go through that. Next, oscillator unit ಅಂದ್ರೆ ನಮಗೆ ಗೊತ್ತಿದೆ, where it generates clock signals or the frequency ಅಂತ ಹೇಳ್ಕೊಬಹುದು. And he has given an analogy saying it is equivalent to the heartbeats. Okay, so a microprocessor or the microcontroller is a digital device made up of digital combination and the sequential circuits. ನಮಗೆ ಗೊತ್ತಿದೆ, the instruction execution of a microprocessor or controller occurs in sync with the clock signal. It is analogous to the heartbeat of a living being, which synchronizes the execution of the life. So ಅವನು ಅನಾಲಜಿ ಕೊಟ್ಟಿಯಾನೆ ಹಾರ್ಟ್ ಬೀಟಿಗೆ. ನಾವು ಹಾರ್ಟ್ ಬೀಟ್ ಇಲ್ಲ ಅಂದ್ರೆ ಹೆಂಗ್ ಜೀವ ಮಾಡಕ್ ಆಗೋದಿಲ್ಲ, ಅದೇ ರೀತಿನೇ the oscillator circuit or the oscillator unit is very very important, that acts as heartbeat for the embed systems. Without that, we cannot run any program, or we cannot do any task. For a living being, the heart is responsible for the generation of the beat, whereas the oscillator unit of the embedded system is responsible for generating the precise clock for the processor. So without clock, we cannot do anything. So that's what he said, that certain processor, the oscillators or controllers, certain processors or controllers integrate a built-in oscillator unit and simply require an external ceramic resonometer or the quartz. So certain processor, this oscillator unit is already present, but they need one resonator. So just look at the diagram. You might have seen this kind of structure in your in motherboard, right? So quartz crystal resonator and the crystal oscillator, right? So it is connected external capacitor and the resonator. Observe here, capacitor and the resonator, so that will generate the required clock signals, and it is connected externally, but the oscillator unit is inbuilt, or it is present uh, within the microprocessor or the controller ಅಂತ ಇಲ್ಲಿ ಹೇಳ್ಬೋದು, right? Or sometimes the oscillator unit is external to the microprocessor, it will generate the clock signals, and that is fed as input. For example, 8085 is one such kind of a microprocessor where the oscillator unit is generated externally, right? Yes, even most of the processors have oscillator unit externally. Next, real-time clock RTC. It's very simple. Uh, Real-time clock RTC is a system component responsible for keeping track of time. So in order to keep the track of time, so we need one system called as a real-time clock. RTC holds information like the current time in hours, minutes, and seconds, either in 12-hour format or the 4 hours format, along with the date, month, year, day of the week, etc., and supplies timing in reference to the system. Okay. Next, RTC is intended to function even in the absence of power. Yes, so it is ಬ್ಯಾಟ್ರಿ ಬ್ಯಾಕ್ಡ್ ರಿಮೆಂಬರ್ ದ ಆರ್ ಟಿ ಸಿ. ನಾವು ಎಷ್ಟೋ ಸಾರಿ ನೋಡಿದೀವಿ, ನಮ್ಮ ಲ್ಯಾಪ್ಟಾಪ್ ಆಗಿರ್ಬೋದು, ಕಂಪ್ಯೂಟರ್ಸ್ ಆಗಿರ್ಬೋದು, ಒಂದು 15 days. ಬೆಸ್ಟ್ ಥಿಂಗ್ ಇಸ್, ಈಗ ನೋ ದ ಮಾಡರ್ನ್ ಕಾರ್ಸ್ ಎಲ್ಲ ಇರುತ್ತೆ. ಕಾರ್ನಲ್ಲಿ ನಮಗೆ ಡ್ಯಾಶ್ ಬೋರ್ಡ್ ಅಲ್ಲಿ ವಿ ಕ್ಯಾನ್ ಸಿ ದ ಓಡೋಮೀಟರ್ ಅಂಡ್ ಆಲ್, ಅಲ್ಲಿ ಕೂಡ ಟೈಮಿಂಗ್ ಕೂಡ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಈವನ್ ಬೈಕ್ ಅಲ್ಲೂ ಕೂಡ ಸಮ್ ಟೈಮ್ ಕೊಟ್ಟಿರ್ಬೋದು ಅನ್ಕೋತೀನಿ, ದ ಮಾಡರ್ನ್ ಬೈಕ್ಸ್ ಅಲ್ಲೆಲ್ಲ. ಬಟ್ ಕಾರ್ ಅಂತೂ ಇದಿದೆ. ನಾವ್ ಎಷ್ಟೋ ದಿನ ಕಾರ್ ಆನ್ ಮಾಡಿರೋದಿಲ್ಲ, ಬಟ್ 15 days ಅಥವಾ 1 month ಆದ್ಮೇಲೆ ನಾವು ಆನ್ ಮಾಡಿದ್ರು ಕೂಡ ಅಲ್ಲಿ ಅದು ಕರೆಕ್ಟ್ ಆಗಿ ಟೈಮ್ ತೋರಿಸುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ದ ರಿಯಲ್ ಟೈಮ್ ಕ್ಲಾಕ್. ದಟ್ ಇಸ್ ಆಲ್ಸೋ ಒನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಎಂಬೆಡ್ ಸಿಸ್ಟಮ್. RTC are available in the form of integrated circuits from different semiconductor manufacturers like the Maxim or Dallas, ST Microelectronics, right? Yes, remember it is power backed, ಅಂದ್ರೆ battery backed ಅಂತ. Next, watchdog timer, very very important. Why it is called as the watchdog timer? It watches the execution of the software. That's it. Or the codes. That's what it is called as the watchdog timer. You can observe the diagram here. Microprocessor control, microprocessor or the controller, microcontroller anta ide. Illi reset pin ide, watchdog reset anta. It's the watchdog timer, free running counter. So what it does, whenever the programs uh, or whenever a program is getting executed, the watchdog timer either will increment the count or will decrement the count. Okay, if the program doesn't execute that prescribed within that prescribed count, so what it does, it will reset the microprocessor. So that's what it is called as the watchdog timer. Andre program ಏನಾದರೂ ತಪ್ಪಾಯಿತು ಅಂದ್ರೆ, program correct time ಅಲ್ಲಿ execute ಆಗಿಲ್ಲ ಅಂದ್ರೆ, it will monitor that. A watchdog timer, or simply a watchdog, is a hardware time for monitoring the firmware execution. Depending on the internal implementation, the watchdog timer increments or decrements free running counter with each clock pulse and generates a reset signal to reset the processor. If the count reaches 0 for a down counting watchdog or the highest count value for an up counting watchdog, then it resets the processor. Keep in mind, if the watchdog counter is in enabled state, the firmware can write a 0 to it before starting the execution of a piece of code. ಅಂದ್ರೆ ಯಾವುದೇ ಪ್ರೋಗ್ರಾಮ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಅಲ್ಲಿ ಕೌಂಟ್ ನ 0 ಮಾಡ್ಕೊಂಡ್ಬಿಡುತ್ತೆ, ಅಥವಾ ಅಥವಾ ಹೈಯೆಸ್ಟ್ ಕೌಂಟ್ ನ ಪುಟ್ ಮಾಡುತ್ತೆ. ಈಗ ಟೇಕ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್, ರೈಟ್? ಸೊ ಐ ವಾಂಟ್ ಟು ಎಕ್ಸಿಕ್ಯೂಟ್ ಒನ್ ಪ್ರೋಗ್ರಾಮ್ ವಿತಿನ್ 100 seconds. ಅರ್ಥ ಆಗ್ತಿದೆ? ವಿತಿನ್ 100 seconds. ಸೊ ವಾಟ್ ಐ ಡು, ಐ ವಿಲ್ ಪುಟ್ ಕೌಂಟ್ ಆಸ್ 100 ಆಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೌಂಟ್. ಸೊ ವಾಚ್ಡಾಗ್ ಟೈಮರ್ ಏನ್ ಮಾಡುತ್ತೆ, ಅದನ್ನ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಇಟ್ ಇಸ್ ಸೇಮ್ ಆಸ್ ಈಗ ಟೈಮರ್ ಅಂತ ಫಿಕ್ಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಅದೇ ರೀತಿ 100 seconds ಫಿಕ್ಸ್ ಮಾಡುತ್ತೆ, ವಾಚ್ಡಾಗ್ ಟೈಮರ್ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ವಿತ್ ಇನ್ ದ 100 seconds ಒಳಗಡೆ ಆ ಪ್ರೋಗ್ರಾಮ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗಬೇಕು. ಅಥವಾ ದ ಪ್ರೊಸೆಸರ್ ಮೇ ಕೀಪ್ ದಟ್ ಕೌಂಟ್ 0 and it may start increasing that. Okay, it may start increasing that is 0 1 2 3 up to 100. So sorry, 99 up to 99 ಅಥವಾ 1 ಫಿಕ್ಸ್ ಮಾಡಿದ್ರೆ 100 ಅಂತ ಆಗುತ್ತೆ. ಸೊ ಒಂದ್ ವೇಳೆ ಏನಾದ್ರು ಆ ಟೈಮ್ ಮೀರ್ ಹೋಯ್ತು ಅಂದ್ರೆ, ಸೊ ವಾಟ್ಸ್ಆಪ್ ಕೌಂಟರ್ ಏನ್ ಮಾಡುತ್ತೆ, ಇಟ್ ವಿಲ್ ರೀಸೆಟ್ ದ microcontroller or the processor, we can say. If the firmware execution doesn't complete due to non-functioning within the time required by the watchdog to reach the maximum count, the counter will generate a reset pulse. Adna again ಹೇಳಿದೆ, ಅದ್ರಲ್ಲಿ ಕೊಟ್ಟಿಯಾನ ಅಷ್ಟೇ, ಮತ್ತೆ ಏನಿಲ್ಲ. If the firmware execution completes before the expiration of the watchdog timer, you can reset the count by writing a 0 to the watchdog register. Most of the processors implement watchdog as a built-in component and provides a status register to control the watchdog timer, like enabling and disabling watchdog functioning, and watchdog timer register for writing the count value. Next point is, if the processor or controller doesn't contain a built-in watchdog timer, the same can be implemented using an external watchdog timer IC, right? So this is not built-in, it is external to this particular microcontroller. He has given some examples like the microprocessor survivor IC DS1232 integrates a hardware watchdog timer in it. Okay, the IC DS1232. In modern systems running on embedded operating systems, uh, the watchdog can be implemented in such a way that when a watchdog timeout occurs, an interrupt is generated instead of resetting the processor. So again, this is a very good process, uh, right? So instead of resetting the um, processor or the microcontroller, so simply they generate one interrupt signal. Okay, that interrupt signal will reset the processor. So that is a good move. The interrupt handler for this handles the interrupt handler for this handles the situation in an appropriate fashion. Uh, that is given in the figure like this. Okay, that's it. Please go through the assignments given, right? And I will very soon upload the programs, software programs, right? Okay, still we have time. Okay, that's it. We'll wind up again. Tomorrow we'll meet with either new module or with the lab programs, right? Thank you.